We live in a metallic world. Metals widely exist in human society. Small items like phones and computers, and large stuffs like cars and constructions. Scientists has done lots of studies on metal 3D printers, combining one of the most important materials and one of the latest technologies in the planet. There are some results, but it is still an in-progress project. What is metal 3D printing? What is the difference between it and traditional 3D printing? How will it affect our economy? And how will it change our daily life? You may get all the answers throughout this video. Before we understand how metal 3D printing realizes, we should first know how traditional 3D printing works. There are three main steps. First, modeling, building a model you want to print. Second, slicing, analyzing your model file layer by layer and let your 3D printer know how to print. Third, printing. Well, printing is printing. And there are also many types of 3D printers, meaning that they use different methods to print an object, such as LOM, SLA, SLS, FDM. Each type has its own advantages and disadvantages. The methods of printing metals are based on or improved from traditional 3D printing. This leads to the first difference, the material. Most 3D printers can only make objects by using deposit materials, like plastic powders. However, current metal 3D printers are able to print items made by metal powders. Although it seems that two are both powders, printing a metallic one requires higher technologies because of metal's own characteristics. Now you may ask, hey, it seems that metal 3D printing has already existed. Why do you say it is an in-progress project? Yes, there are many companies that are manufacturing metal 3D printers, but the printers are all nominal, or not so practical for us, as normal people. The first problem is its cost. Because the printer makes an object layer by layer, point by point, it costs lots of time. Also, the raw material is extremely expensive. The price of aluminum powder for 3D printing is as high as 135 euros, up to 1000 yuan per kilogram, compared to about 30 yuan per kilogram for ordinary aluminum. The second problem is its practicability or reliability. The biggest weakness for metal 3D printing in strength is that the parts are stacked layer by layer, so it has a poor resistance in the stacking direction. It means that in short term, it still cannot be used in constructions. But the modern society progresses so fast that we cannot imagine what metal 3D printing will be like in the next year. Once the technology of metal 3D printing becomes mature, it will bring us a revolution.
Due to the rapid technological advancement, metal 3D printing has grown massively in recent years. Many innovative startups and suppliers have proposed new and increasingly affordable metal 3D printing process and more capability materials. Metal 3D printing is popular in many industries, including the aerospace, automotive, and metal industries, allowing the printing and complex metal parts for a relatively low price when compared to traditional manufacturing process. Recently, there has been many improvements made to metal 3D printers, hybrid system metal deposition, recovery metals, and many other innovative projects means the process is more efficient than ever. So, giving some facts, the 3D printing metal market size was USD 774 million in 2019 and is projected to grow at a CAGR of 32.5% between 2019 and 2024 in terms of value. The Asia-Pacific 3D printing metal market is expected to register the highest CAGR of 33.4% in terms of value during the forecast period. Increasing demand for 3D printing metal from aerospace and defense and automotive and use industry, mass customize of product with complex design and structures, low manufacturing cost and reduce is what caused the market growth and the increase of demand. Now looking at this graph, the 3D printed metal market by regions, USD million. From 2017 to 2024, we can see the massive increase in the demand of 3D printing market. In 2019, there's 774 USD million, and in 2024, it's expected to be 3,159 USD million. This is such a high increase. Products, it results in a graph that looks something like this, where our costs per part rapidly decrease as we build more, soon become dominated by the material cost. This means that it only makes sense, economic sense, to use 3D printing for parts that fall behind this break-even point, which is why it is used so frequently for rapid prototyping. If we can reduce the raw material cost with better supply and decrease 3D printing machine cost, we can lower this line and open more parts to being replaced by 3D printing. That is gradually happening as the cost of these machines lowers, in large parts due to the patients expiring in the last 5 years. Power fusion technologies are based on relatively simple principle. A power source sinister or melts metal powders to create the finished piece layer by layer. The most well-known metal 3D printing technology based on this principle is the direct metal laser sintering, which is DMSL, patented in the 1990s by ERD and EOS. So another major metal 3D printing technology is direct energy deposition. This method involves construction of metal parts through a CLAD laser. During the process, powder is projected by the nozzle and fuses at the outlet through a laser beam to weld together. This method allows for printing directly onto a piece or part, unlike most other technology. Companies such as BEAM, Seneca, and Optimic uses this technology. So now talking about the metal 3D printing materials, among the most common used metal in 3D printing, there is firstly aluminum, mainly used in alloy forms. Aluminum is useful as it offers good resistance and being light. It is mainly used when keeping weight down is essential, such as in aeronautic and automotive industries. Steel is also popular, especially in industrial applications. Steel offers strong mechanical properties and a good surface finish. Due to this, it's the most popular metal used in 3D printing. In addition, there are also metals such as gallium, cobalt, chrome for medical use, and titanium due to its good corrosion resistance and biocompatibility for medical application. Also, precise metal are mainly used in jewelries. Despite its high cost, gold, silver, and bronze are usually used with 3D printing to create complex pieces of jewelry. The main challenge within this, however, is in the finish because of its texture. So, from these, we can see how much and how broad metal 3D printing can be. It can be for medical industries, automobile industry, and even jewelry industry.